Please welcome our keynote speaker, Shailvi Wakhlu, Senior Director of Data at Strava. Shailvi leads a large team of product analysts and machine learning engineers to enable data-informed product improvements in support of Strava athletes. In the past, Shailvi worked at Salesforce, Fitbit, and multiple other data-rich companies, in addition to previously running her own company. As a data leader, she focuses on harnessing the power of data to build great products, clarify strategic decisions, and improve business processes. Today, Shailvi will be presenting her exciting talk, Data Fitness for a Healthy Business. If you have any questions for Shailvi, please make sure to drop them in here in the session chat. Join me in welcoming Shailvi for our keynote talk.
Hello, everyone. Welcome to the keynote at the Data Reliability Engineering Conference 2022. This session today is about data fitness for a healthy business. I hope you're all as excited as I am to dive more into the exciting world of data quality and are pumped to learn about how data quality can affect your business outcomes. My name is Shailvi Wakhlu. I go by the she, her pronouns. I work as the Senior Director of Data at Strava, leading a very wonderful team of analysts and machine learning engineers. For those of you who are new to Strava, we are the leading social platform for athletes and the largest sports community in the world. We have over 99 million athletes in 195 countries, and we are hiring. Today's topics will be a journey to explore the nuances of data fitness. We'll explore what makes data good or bad, why we should care about it, and how we can solve to ensure high data quality. By the end of the talk, I hope you feel empowered with the right mindset to prioritize healthy data, which optimizes your business health. So let's start by trying to understand what makes data good or bad. After all data is not created equal. When people look at a piece of data, it is meant to represent a fact. Those facts can be combined with other facts to create some basic measures. To those measures, you can add context and meaning to create knowledge. That knowledge can help businesses make powerful decisions. However, you may not always know when bad data is masquerading as good data, because data doesn't always reveal its health status. It is possible that the data you are looking at has a mistake or is outdated and not being actively maintained, or that the data is just plain wrong. This is where a curious nature, a healthy dose of skepticism, become kind of useful. Since you don't always know when data is bad, you should be on the lookout for some common scenarios that should prompt a data investigation. One scenario might be when you see data results that should match but don't. For example, you talk to two different teams and they give you completely different sales numbers for the month of April, and you can't figure out which one is correct. At least one of them has bad data. Usually data has some sources of truth or just something that you trust a lot, and some other data shows up that does not match your other data source in absolute or in aggregation. Other times you could see a data result which looks a little bit suspicious. You see something and you don't think that it makes any logical sense. Maybe you were expecting to see something different from the results, and oftentimes you actually have a good reason to know what to expect. But instead you're seeing something odd. Sometimes the suspicious result might actually be accurate, but it still warrants an investigation. In either scenario, improving your understanding of what's going on and chasing down the right answer with your team is an important step in advocating for business success. Based on our investigation, if we confirm that the data that we are seeing is either inaccurate, incomplete, or misleading, then that is indeed bad data. Such data can also be referred to as low quality data, and it can be showing up in many different forms. All of this poor quality data can lead you or your company to make biased decisions, and that can end up negatively affecting your business outcomes. Just to be clear though, when you see something that you don't like seeing or just that you don't want to see, that doesn't mean that you have a data quality problem. If the data is accurate, if it's complete and it isn't misleading, it is good data. Before we go further into importance and solutions, it's important to understand how bad data gets introduced. Even if you have other teams working on the raw pieces, as a person with an ownership mentality, it's helpful when you have a decent understanding of the problem. That way, you can better support the teams that are working on resolving the problems in appropriate ways. And for that, the first step is to understand the life cycle of data. All data actually goes through very similar phases and it happens in a sequential manner. So, first up, we define the features and align the different teams on the definitions. Next, we work on actually logging the data to track and store it. After that, we use some business rules to transform the data into a usable format. Then an analyst is able to interpret the data to solve some business problems. And finally, the data results are shared with the stakeholders. And that wraps up our data lifecycle. After we have identified the data lifecycle, you'll start to see that at every phase of that data lifecycle, there are numerous possibilities to unintentionally introduce bad data. There's a lot going on with this graphic, but I wanted to show the full picture before I dive into a few chosen callouts. I won't cover all the scenarios, but I'm happy to take questions later or in the chat if there's interest. And also, this entire portion is covered in detail in some other videos which are available on my website. Feel free to also snapshot this graphic as well. I actually do that because it functions as a reminder for a lot of common ways how phases where data can become corrupt show up. So let me now jump into a couple of broader themes. Biases in data, in algorithms, are a hot topic right now, and rightfully so. The world is finally realizing that code is ultimately written by humans, and hence there's no such thing as an unbiased piece of code. Someone is training a model, and they decide what training data set to pick. Someone is writing the script, and they are making some assumptions that they think are basic, but maybe not the same basic assumptions that someone else would make. This is honestly a very large topic, and there are a lot of considerations that go into intentionally reducing bias in your data. You have the capacity, unfortunately, to negatively affect very large populations if your algorithm is biased. During the analyzing phase, there are a lot of things that can go wrong. The solutions your team ends up rolling out may be completely blind to the problems faced by some of your users and actively causing harm. As a future business leader or a current business leader, you have to actively solve for some of those potential issues and institute processes that prevent those harmful outcomes. It's no longer enough to try to do good. You have to actively be doing less harm. This is now starting to be an industry-wide expectation, and it's also just the right thing to do. If you don't design inclusively, your products will end up having a very short shelf life, and someone else will eventually undercut you with a better product that doesn't cause harm. Your reputation could also be at risk. And if you don't make the right decisions with ethical concerns, that's a problem. Actively solving means you are intentional about understanding the problem and coming up with a roadmap for those solutions. Human error is, again, something that consistently shows up throughout the data lifecycle. And it's obviously hard to know when it'll show up because it's unintentional. People don't do that consciously, but it shows up. Maybe someone has just fat-fingered a piece of code. Maybe they made a logical error, or perhaps their understanding is not accurate, and they're making a bad assumption, which results in a mistake. Maybe they mislabel something, or they forget what formula they need to apply. All of these and other similar scenarios are bound to happen because humans are not perfect. Eventually, though, you have to understand that errors will happen. If you assume that they will happen, how do you then go about and plan for those scenarios? What will be your communication plan? How will your preemptive process occur that tries to reduce those errors? What happens if something breaks, and by when would you need to fix it? Is the downstream impact possibly significant enough that you should add a strict code review standard? And how much will the process burden slow your team down? This is a very long list of things to do, and you can make smart decisions based on the business that you're in and also see the costs that are associated when things go wrong. To dive into the cost piece a little more, we come to the second main topic for today. Why should you or any leader in your business care about bad data and proactively try to solve it? Well, it's costly. Poor data quality can be immensely expensive and in a lot of different ways. Just the fact that bad data exists on its own, that doesn't make it costly. But when you discover bad data, or you don't discover it, but use it to make very unfortunate decisions, those costs can really start to add up. One of the biggest concerns you have to think about is trust. It is really hard to put a number on the cost of losing trust. Imagine a scenario where bad data just went unnoticed or it went unchallenged and it got presented to someone who later learns that that initial data you presented to them was incorrect. That can be super damaging to your reputation. Depending on who you presented the data to, there can be a lot of consequences to fix with that lowered trust that you now have. Losing your customers' trust can be very damaging even when they don't directly face harm due to the poor data. Even them just hearing about it and understanding that you had a big enough mistake that you now have to publicly admit, maybe it causes them to question your competence in creating the products that they use. Your competition will always use these opportunities to leap into showing that they're much better than you, and that can be very damaging for your brand as well. And in fact, if you are in that unfortunate position, or if your customers are in that unfortunate position where they faced direct harm, then of course there's a whole host of other reasons that the trust is lowered. Nobody wants to feel that they are participating in a product that is going to lead to something where there's something inaccurate, incomplete, or misleading in some way. If the bad data was presented maybe to your board or your shareholders, they can also lose faith in your abilities as a team or as an individual. In a 2016 KPMG study, it said that 84% of CEOs are concerned about basing decisions on bad data. So it's important to factor in stakes for a data moment and be careful about the consequences of getting something wrong. Besides trust, the other big space that you have to worry about is obviously revenue and opportunity loss. You could either lose money right away due to bad data, maybe something like your data pipeline broke and now you're immediately losing revenue. I actually did do that once, unfortunately. But you could also have something where you are monetizing data and now you're missing data, so hence you're now missing money. Maybe you are also just losing revenue due to inaccuracy. So you have sort of an automated pricing model and that's broken, and you could end up charging less and you could lose revenue. And you can't later go back to customers and says, oops, I actually charged you less. Whatever you did, that's done. So maybe your data is misleading in some way, which makes your customers feel that you are more expensive than you actually are. And so they are less likely to sign up. All of these scenarios are immediate consequences to you losing revenue due to bad data. There's also an opportunity cost that can be lost. If your analytics had a bad data problem and thus led you down a very different path, which makes you less money than if you had the right data and the associated right insight with it. Just fixing the bad data, that's also a very direct cost. If there's something wrong with it, you have to spend time and resources, and all of those costs can add up. It'll usually be much higher than if you caught the problem really early and fixed it very soon. Another big cost of bad data, is the harm to real people through bias. If your data incorporates hidden bias, that can cause harm to people, and it's a real cost. It's not just monetary. And one unintentional nudge to a seemingly independent piece can set up this whole domino effect that can cause a host of downstream problems. This can be triggered by something as innocuous as you made a simple design change to your data architecture, and you just didn't anticipate a scenario of how things would be downstream. Those unintended consequences will end up possibly excluding folks from the benefits of your product or worse. There are tons of examples of this in the real world, where biased data led to harm. The pandemic alone has shown the world that a lot of examples of how biases can perpetuate in data can cause bad consequences. These consequences can be costly to your business because causing harm is never a great sales pitch. In some cases, you or your company can also be held liable, depending on what you got wrong, why it was wrong, what the outcomes resulted in. All of that can add up. Some industries, such as finance, health, etc., they have very strict rules. So if you work for any of those in any of those industries, you have some responsibilities that are almost framed as part of compliance. You have very strict guidelines. What this is what your data should meet, and there are monetary and other consequences if you don't meet them. In other situations, maybe you don't have compliance requirements as such, but you still have regular legal standards to meet. If your data facilitates something that ends up hurting people in some way, you could be legally responsible for those mistakes. These mistakes are, of course, expensive, but they can also be compounded by how you as humans respond to those mistakes. Ethical behavior is not just good for your soul, it's also a smarter business strategy. Looking at more internal facing costs, bad data is just, it's time consuming, it's painful to fix, and it's a productivity loss for your data teams. Data scientists end up spending a lot of time fixing bad data. They have to find an error, they have to bring it to someone's attention, they have to figure out what's going on, then they have to communicate it, especially if it was an important step to making a decision, and they have to stop that whole pipeline of things from occurring. Then they have to actually fix it. They have to hunt down, why did this happen? What's the source it's coming from? They have to validate and cross-check, QA everything, and all of that, including making the actual fix. It takes up a lot of time, and you have to put up guardrails to make sure that it doesn't happen again. So all of that is a productivity loss for your team for something, if it had been caught early, would have been just quicker. And finally, not to be underestimated, there is the morale aspect. At the end of the day, it usually comes to data teams and other closely related functions to communicate and fix issues, even when it's not their fault that something broke. It's important for them to do that because they eventually want their colleagues to trust them and the data that they share. However, all of this can feel very tiring. It can feel like this additional burden that data teams have to carry, and it can be demotivating to be in these very high-stakes situations where they don't see enough recognition for their hard work. If the data issues keep happening and business leaders don't invest in the resources that would be required to prevent these situations, it can feel especially tiring to keep tolerating these problems. Ultimately, people lose jobs because their talents are not being used optimally, and that is something that everybody should be interested in preventing. Now that we know why this is important, let's dive into the how. How can you help ensure that there is good data quality in your company? So first up, acknowledge that data fitness is something that's a cross-functional priority. Whether you reside in a data team or you're a consumer or a creator of data, in all those cases, you have some responsibility in ensuring that data fitness is being prioritized. As we saw in the data lifecycle overview, there are many parts to the data lifecycle, and literally any of those parts could have something wrong with it. All of those parts can have multiple owners who need to come together to fix something. You can diagnose the problems to see exactly which step something is breaking, but cross-functional collaboration is critical to keep things moving as quickly as possible. Do keep in mind that sometimes, unfortunately, you can't fix everything that went wrong in the past. Sometimes something broke and it's a permanent and unfixable gap. However, you can cure the problem for the future, and you can add some guardrails in place to flag issues going forward. So Whoever is the primary owner of doing the investigation should ideally start by looking for the very obvious reasons why one might be encountering or suspecting bad data. Of course, now there's many tools on the market that help you do this in an automated fashion. So first obvious question to ask is this really bad data? If you were looking at two numbers, were they even supposed to match, or were they always meant to represent different things? And if the results are suspicious, what assumptions have led to those suspicions? And then look at the actual data set. Was that data set even built for your use case? This is a very common problem that occurs, where people are just they're looking for the right answer, but in the wrong place. And finally, is there some known bug or pipeline issue, which means that your bad data issue is either temporary or it has a fix and you just have to dive into it. If none of these obvious reasons are the answer, then it's time to be methodical and go step by step to find the root cause. Again, there are tools that can help with this part in an automated manner. Start with the data lifecycle in reverse order. For every phase, verify if the phase before it had the right data. This way you can identify the exact phase in the life cycle where something is breaking. When you find the phase where the data is breaking, go through the common root cause examples and create a hypothesis about what might be happening. Hypothesize, test, and validate. And keep repeating that process until you find something that explains your issues fully. Final sanity checklist is to just logically go through your problem and document what you know and what you need to figure out. I go for the journalistic favorite questions of trying to document a story and focus on what happened, where did it happen, when, why, who, how, all of that. As I go through this, it helps to rope in other people to walk through my logic, or even look up data dictionaries or any other documentation that can just help me validate my initial assumptions. The truth is out there. You just have to keep breaking down the problem until you can find that little specific issue. So whether it's you or someone on the team, especially if you're not using automated tools, you can encourage your team to write some basic scripts that help check the issue faster, which can result in less data corruption. The more familiar your team is with your data and its most common problems, the easier it is for them to write common scripts or even make visualizations that make it easy to pinpoint and fix problems. Just basic volume checks go a really long way. Like, are you inconsistent with the rows of data, or is there something that just isn't showing up? Things that help you quickly identify missing data or where data might be duplicated. That's also very useful to quickly find what's going on. And finally, being able to break down data by different dimensions, that's really helpful, especially when your data is really large, because you may realize that, okay, everything's fine, but there's just this sort of one segment of data that has a problem. So pre-made scripts or tools can be very useful and very time-saving, and that can really go a long way for you to do right by your data. From a process perspective, I think that it is important to identify and enforce some coding practices that can just help bring everybody on the same page. Data teams should have reusable modules wherever possible. It's a really helpful practice when there's a time crunch and you need to check a bunch of things in a short amount of time. Documentation, just like any other function, documentation is super critical. Code should be centralized. Documents should be easily accessible. Again, there's a lot of tools that help you do that. It also builds in some basic amount of consistency. And finally, you can ask for alerts to be added to the data pipeline, where you flag if something goes wrong. Maybe you can just tag some thresholds about, like, okay, what's something that should be the cause for you to launch an investigation. So hopefully all of this has given you a decent idea of what to expect. Data fitness can be quantified by how many good data practices you follow and where you have gaps. So this is a recap of the differences between good and bad data practices. Good data, well-maintained, well-documented. It uses simple and easy to understand and consistent terminologies. There's an effort to centralize code, automate as many things as possible. And there is also a deep focus on creating simplified, curated data sets that have wide use cases. An intentional governance strategy and clear ownership around who does what, and also having a regular audit process to find flaws that can be fixed and prevented in the future. And yeah, bad data quality is kind of the opposite of that, and that's what you want to stay away from. So remember that prevention is always better than cure. So put in your efforts upfront to foster those good data practices on your team, or to find the right tools that can help you automate those pieces. You have authority over your team's bandwidth for the maintenance work that enables all of this. So you can have a huge impact on the company's bottom line, and that's a good thing to work towards. Very quickly, wanted to leave you all with some additional research and reference material. I also have some examples and additional technical details in some of my other talks that are linked on my website. I also mentioned earlier that I have another talk where I go through the phases of bad data more extensively, and you can find that on my website. And with that, thank you all for listening. And thank you so much to the Data Reliability Engineering Conference for hosting me. I hope this was useful. You can either ask questions on chat or even tag me on Twitter if you have a story or a follow-up question. And if you want to get in touch with me, you can contact me through my website. I hope you all enjoy the rest of this amazing conference. I know there's some fantastic speakers out there with a lot of knowledge to drop. So have a great day, everyone, and thank you.